Hi everyone, my name is Laura Marzinski. In this presentation, I'm going over the top 20 sOOPy security and object-oriented program principles. These concepts help support our company's goal of adding security into every level of our environment, from development to IT to the end user. Each slide explains one principle and how it helps us design a safer and more reliable systems. A class is a blueprint used to create objects. It keeps related data and functions together so the system stays organized. The main idea is building clean, reusable pieces of code. In our environment, a class, like a user class, helps us consistently store username, roles, and permissions. Encapsulation protects data by keeping it private and only allowing access to approved methods. The main idea is preventing unauthorized or accidental changes. In our environment, this is like resetting a password through a function instead of editing the password directly. Inheritance lets one class reuse the properties and behaviors of another class. The main idea is saving time and keeping code consistent. For us, an admin user class can inherit from the user class and just add extra abilities. Modularity breaks systems into smaller, easy to manage parts. The main idea is improving organization, security, and troubleshooting. In our environment, having a separate login module and a separate payroll module keeps things cleaner and safer. Process isolation keeps running programs separate so one can't damage or interrupt another. The main idea is stability and protection. A good example is when one browser tab crashes but the entire system stays up. Domain separation divides different areas of systems so each can apply its own security rules. The main idea is containing damage if something goes wrong for us. That means keeping the employee domain separate from the administrator domain. Open design means the system stays secure even if the design is public. The main idea is that security should not depend on secrecy. An example is modern encryption algorithms that are published online but still secure because the protection comes from the keys. Defense layering uses multiple security measures at the same time. The main idea is that if one layer fails, others still protect the system. For example, using a firewall, antivirus, MFA, and an intrusion detection system together. Least privilege gives users only the minimum access they need. The main idea is limiting damage if an account is hacked or misused. For us, that means an employee can view reports but not edit or delete them. Abstraction hides unnecessary details and shows only what someone needs. The main idea is reducing confusion and preventing mistakes. A good example is pressing a submit button instead of dealing with all the code behind it. Polymorphism allows a single function to work in different ways depending on what it's used with. The main idea is flexibility and an easier code expansion. For example, the same print functions can print documents, image, or PDFs differently. Resource encapsulation protects system resources like files, memory, and storage by controlling access to them. The main idea is preventing unauthorized programs from touching things they shouldn't. An example is allowing only one secure service to read certain system files. Information hiding conceals internal details and only reveals what is necessary. The main idea is reducing what attackers can learn. For us, hiding technical system errors keeps hackers from getting clues about the system. Minimization removes unnecessary features, permissions, or services. The main idea is reducing the attack surface. A good example is turning off unused ports on a switch or uninstalling programs nobody needs. Complete mediation text permissions every time a resource is accessed. The main idea is making sure access is always verified. For example, if someone's permissions are removed, they instantly lose access to that folder. Failsafe defaults mean denying access unless permission is clearly granted. The main idea is staying secure even when things fail or are misconfigured. A normal example is when new users starting with no permissions until they are assigned. Simplicity keeps systems straightforward and easy to understand. The main idea is reducing errors and vulnerabilities. A simple login screen with only the needed steps is more secure than a complicated one. Audit logging records important events like logins and file accesses. The main idea is tracking activity and spotting suspicious behavior. For us, logs help us see who accessed sensitive data and when. Access control manages who is allowed to access specific information for resources. The main idea is preventing unauthorized access. In our system, Active Directory groups decide who can open folders like HR or finance. Input validation checks data to make sure it's safe and correct before the system accepts it. The main idea is blocking harmful inputs and preventing attacks. For example, validating a login form blocks dangerous characters used in attacks like SQL injection. This wraps up my flashcard deck on the top 20 SOOPy terms. These concepts helped us build secure systems, protect data, and support a safer environment for both users and developers. Understanding these principles is a key part of strengthening our cybersecurity posture across the entire company. Thanks for watching. These are the reference used for this presentation. The main source was the Nebraska Gen Cyber modules, which explains the cybersecurity first principles in detail. I also use supporting cybersecurity materials from NIST, OWASP, the Center for Internet Security, and Standard Security textbooks.